During normal operation of the gas turbine, a portion of the compressor discharge air is internally extracted through the wheel space that exists between the 16th and 17th compressor stages. This air passes through the hollow centers of the distance piece and the turbine rotor. In the turbine section, the extracted air cools the first and second stage turbine buckets. Cooling air also flows through the second stage aft side wheel space and the third stage forward side wheel space. Cooling air enters each first and second stage bucket through a cavity between the wheel and the base of the bucket dovetail. Cooling air flows through the longitudinal air passages and exits from holes at each recessed bucket tip. The air seals the bearings by containing within the bearing housing any lubricating fluid that leaks past the oil deflectors. Air is directed to both ends of each bearing housing and flows along the journal into the bearing cavity. This provides a pressure barrier to the lubricating fluid. Compressor discharge air is directed internally through the partitions of the first and second stage turbine nozzles to provide nozzle cooling. This air is channeled internally to cool the forward surface of the first stage turbine wheel. There is a cooling annulus between the inner and outer walls of the turbine shell. This annulus has ambient air supplied by the exhaust frame blowers continuously flowing through it. Part of the air travels forward, cooling the turbine shell, and exits into the turbine compartment. The remainder of the air flows aft through the exhaust frame strut passages. The airflow through the exhaust strut divides, with a portion directed through passages to cool the third stage turbine aft wheel space. The remainder flows into the load shaft tunnel, where it is discharged through a duct to the atmosphere. Air entering the filter is directed in a tangential flow around the inside wall of the filter housing. Centrifugal separation removes particles, which are caught in the vertical slots draining to the bottom cavity. Flow is then directed through the porostone tube, where diffusion through millions of tiny openings filters out the most minute particles. During full-speed operation, compressor discharge air is fed into the air cylinder of VA2-1. This compresses the spring and closes the butterfly valve. The compressor is thus able to sustain maximum airflow. During the startup sequence, the compressor bleed solenoid valve 20CB-1 is de-energized. Air extracted from the 11th stage of the axial flow compressor is vented to atmosphere through VA2-1 and VA2-2. This 11th stage extraction, together with the inlet guide vanes in the closed position, limits airflow through the compressor and prevents compressor pulsation. When the turbine reaches approximately 95% of rated speed, the control system energizes 20CB-1. Compressor discharge air, taken from the combustion wrapper, is directed through the compressor bleed solenoid valve to VA2-1 and VA2-2. This pneumatically closes the butterfly valve in each compressor bleed valve and allows normal full-speed operation of the turbine. Throughout all modes of turbine operation, fifth stage compressor extraction provides cooling and sealing air for the turbine bearings. Bearing sealing air to the number 1 and number 3 bearings is vented through the lube oil drains beneath each bearing assembly. Bearing sealing air to the number 2 bearing is vented through the cooling and sealing air exhaust piping to the exhaust plenum. Air is extracted internally from the 16th stage of the compressor and travels through the hollow centers of the distance piece and turbine rotor. This internal extraction cools the interior of the first and second stage buckets and the spaces between the second stage and third stage turbine wheels. Compressor discharge air is directed through the partitions of the first stage nozzles to provide internal impingement cooling and exits through sidewall holes to provide external film cooling. In addition to cooling the second stage nozzles in a similar manner, compressor discharge air passes through the second stage nozzles into the second stage diaphragm. The second stage diaphragm directs the cooling air past the aft side of the first stage wheel and past the forward side of the second stage wheel. Compressor high-pressure seal leakage air cools the forward side of the first stage wheel space and exits into the hot gas path. Throughout the operation of the turbine shell and exhaust frame are cooled by the two exhaust frame blowers operating simultaneously. A portion of the cooling airflow is directed between the inner and outer walls of the turbine shell and exits into the turbine compartment. The remainder of the cooling air flows through the exhaust frame strut and through passages to cool the aft side of the third turbine wheel and load shaft tunnel. If either 88TK-1 or 88TK-2 fails during turbine operation, the respective pressure switch, 63TK-1 or 63TK-2, will open and an alarm will be enunciated. The turbine will continue to run with one blower operating. However, if one blower does fail, the turbine must operate at a reduced load because of the decreased rate of cooling airflow. While the turbine is being unloaded, the cooling and sealing air system continues to cool and seal the turbine bearings and cool the interior turbine components. When turbine speed eventually drops to 95% of rated speed, the control system de-energizes compressor bleed solenoid valve 20CB-1. The compressor discharge air, which actuated the compressor bleed valves, is vented through 20CB-1 and the spring-loaded compressor bleed valves open. Air from the 11th stage of the compressor is again vented through the exhaust plenum. This prevents compressor pulsation during the turbine deceleration period. The turbine will shut down automatically if there is a malfunction or loss of power affecting both exhaust frame blowers. Reduced air pressure will cause the pressure switches 63TK-1 and 2 to open. This will cause an alarm to be enunciated and the control system will initiate a normal shutdown.